All right, welcome. Today, we are going to dig into one of the most fundamental, but maybe least visible changes in modern MySQL. I'm talking about the move to a transactional data dictionary in version 8.0. And look, this wasn't just some minor tweak. It was a complete top-to-bottom reimagining of how MySQL keeps track of its own information.
You know, you've probably typed create table thousands of times in your career, but have you ever really stopped to think about what's happening under the hood? It feels so simple, right? But for years, that one little command kicked off this surprisingly fragile, kind of disorganized process. And today, we're going to pull back that curtain.
Okay, so here's our game plan. We're going to start with the chaos, the old metadata mess. Then we'll see how MySQL 8.0 came in with this beautiful, central, atomic solution. We'll peek inside to see how it stays so fast, connected all to the physical files on disk, and then, most importantly, we'll talk about why this whole thing is such a huge win for you.
All right, so first up, the old metadata mess. To really get why the new system is such a game changer, we have to go back in time. We need to appreciate the chaos it replaced. Let's take a look at how MySQL used to keep its own notes. Honestly, the best way to picture the old system is just a super messy desk. Imagine trying to run a business where all your critical information, your invoices, your contacts, your to-do lists, are on random sticky notes, napkins, and scraps of paper, just scattered everywhere. It's not just inefficient, it's incredibly risky. One wrong move, and the whole thing falls apart. And look, this wasn't just some abstract idea. The metadata was physically scattered across a whole zoo of different file types. You had your .frm files for the table structure, .par files for partitions, .opt files for database level options. It was a mess. But here's the real kicker. The storage engine InnoDB kept its own separate copy of a lot of this information. You had two sets of books for the same data. What could possibly go wrong? So what does all this disorganization lead to? Well, it leads to the single biggest headache of the old system. DDL statements, your create, your alter, your drop, they were not atomic. This meant an alter table command could literally fail halfway through. It would update some of the metadata files, but not others, leaving your table in this broken, inconsistent state. It was an absolute nightmare for crash recovery. Okay, so after all that chaos, how do you fix it? How do you clean up that messy desk? Well, you get a real filing cabinet, right? A single, organized place for everything. And that's exactly what MySQL 8.0 did. It introduced the hero of our story, the Transactional Data Dictionary. So the data dictionary, it's pretty much what it sounds like, a single, unified central repository for all the metadata. But here's the absolutely crucial part. It's stored inside InnoDB tables. By moving the database's notes about itself into the transactional engine, the metadata suddenly gets all the same protections as your actual data. The same crash safety, the same atomicity. It's like the master library card catalog for the whole database. And this new structure gives us the single biggest win of the entire system. I'm talking about atomic DDLs. Because all the metadata changes are now wrapped in a single transaction, the operation is an all-or-nothing deal. If the server crashes in the middle of a big alter table, on restart, the system just rolls the whole thing back. No half-finished changes, no broken tables. For reliability, this is a total game changer.
Okay, so I know what you might be thinking. A central system sounds great, but doesn't that create a massive bottleneck? I mean, if every single query has to go look up info in the same spot, isn't that going to be slow? That's a great question. And the answer lies in a really clever caching system.
To make sure the data dictionary doesn't grind everything to a halt, MySQL is smart. It doesn't go all the way to the disk every time it needs to check, say, a column's data type. Instead, it relies on this slick two-level cache right in memory that makes metadata access incredibly fast. Think of it like a mechanic in a workshop. When a thread needs a piece of information, it first checks its own personal toolbox. That's the thread's local cache. Super fast, nobody else can touch it. If the tool isn't there, it looks up at the shared tool wall in the workshop. That's the shared cache, available to all threads. Only if it's not in either of those places does it have to make the long walk back to the central warehouse, the actual data dictionary tables on disk. This keeps disk I/O to an absolute minimum. All right, so we've been talking a lot about these logical ideas, the dictionary, the caches, but let's get back to reality for a second. What does this actually look like on disk when you're looking at the files in your data directory? How does it all fit together?
So, when you look in your data directory, you see your .ibd files, one for each table, containing all your data and indexes. But the unsung heroes of this whole story, the files that make all this transactional magic happen, are the logs, specifically the undo logs and the redo logs. First up, the redo log. This thing is the database's ultimate safety net. The best way to think about it is like an airplane's flight recorder. Every single change you make to your data is first recorded in this log before it even touches the main data files. So if the server power gets cut, no problem. On restart, MySQL just replays that log and brings the database right back to the exact moment before the crash. It's all there.
And then you've got its partner in crime, the undo log. This log does the opposite. It stores the before picture of any data that's being changed. And it does two absolutely vital jobs. First, if you decide to roll back your transaction, the undo log has the original data to put everything back. Second, it's the key to MVCC, allowing other transactions to see a consistent snapshot of the database without being blocked.
Okay, so this diagram really ties it all together. Let's walk through it. A transaction starts. First, it writes the before image of the data to the undo log. Then, it goes and modifies the actual data page in the IBD file. But crucially, the description of this entire operation, the change to the undo log and the change to the data page, is first written safely to the redo log. It's this beautiful, careful dance between these components that gives us those ironclad ACID guarantees we depend on.
All right, we have gone super deep into the weeds here, so let's pull back up. After all this technical talk about logs and caches and dictionaries, what does it all mean? What's the actual real-world payoff for you, the developer or the DBA?
Okay, number one, reliability. It's huge. Atomic DDLs mean you can finally trust your schema changes to either work completely or not at all. 2, performance. Getting rid of all that file system overhead and using smart caches makes things faster. 3, total crash safety. Your metadata is now just as safe as your data. And finally, management. It's just easier. No more hunting for random .frm files to figure out what a table looks like. This quote from the Alibaba Cloud community really wraps it up nicely. They say, the data dictionary secures access to metadata, lowers the cost of storage and management, and significantly improves access efficiency. It's not just a new feature. It's a foundation that makes the whole system better. So, I want to leave you with a kind of mind-bending idea. There's this powerful concept in the database world that the log is the database, and the actual data files you see are really just a cache of the log. After everything we've seen today about how critical the read log is for durability and recovery, what does that change about how you think about your data? It's a fun one to chew on. Thanks for joining this explainer.